welcome to the sampling and modeling part 3 of the exercise that we've been doing. So in our previous exercise, we see how we can fix this error by controlling your parameters. Similarly, we looked at one of the example file that I showed you, and we also decided on our best performing model, the model number 555. So in today's exercise, we'll be looking at generate and validate.js script. So we'll use this script to generate our final model based on the best parameter that we found. And we'll also look at some of the post-processing that was applied in this paper, and there are also some independent data that were collected after the modeling modeling effort, and we'll also see the final independent validation. And finally, we'll be able to export the RICE map for the given year 2020. So let's go and look at the script that we'll be playing today is the generate and validate. And as other script, the input needed block is where you'll be making changes. The LT2 is the sampling table that we saw in our previous video. Level 0 and level 1 are the non-RICE and RICE data points for the independent validation that was conducted. Connected RICE map is the connected pixel output that we have exported, and through the video I'll show you how you can export that connected pixels as well. The year is 2020, and this is the label as before. The 0 label property and 1 label property, I have them as a separate because those files were provided separate and they had different label property, the space over here. So to handle that, we have two different property. If you have the same property, you can just keep them same, and then I'm removing any of the flag data points and adding the geometry. The path is where is the path to our composite, and as before we'll replace this path with the correct path, which is ss put on, and remember the ss was attached to it. The export path is the final export for the RICE map, which I'll show you later. Here are the parameters that needs to be changed based on the CSV that we found. Remember, our parameter was model was model 555, the parameter of which is also shown in here. We can double check that. Number of trees is 120, mean leaf population is 3, back fraction is 0.8, max nodes, if you don't see anything, the non means the null. That's the way you represent non value in JavaScript, with the null. So max nodes is null, and your variables per split is also null. So I'm just going to go ahead and just use the same value that's provided there. So variables per split is null, this value is 3, 0.8, and null. So now you've changed your parameters. Again, this script is very similar to parameterized model, where we are importing our Landsat indices, image, Sentinel-2, Landsat 8 top of atmosphere tassel cap, Sentinel-1 ascending, descending, and the SRTM topographic variables. Finally, adding them all together to make our final imagery, where we will be making classification based on, and then simply adding to the map for the visualization purpose. In the sampling, again, it's the same story as selecting the bands and then doing sampling on your points at 30-meter resolution, also keeping a seed so you'll have the same points when you're experimenting. So this is where the parameters that we provided earlier are taken and then put it in a single variable called parameters, which are then sent to this random forest function that gives us that classifier, and basically the information from the classifier are printed, and finally the classifier is used to classify our final imagery, and the rice map is taken out by equaling that classified image to a value of 1. So if you go ahead and run this, just to be able to see something. So these are your variable importance that's coming out from the random forest script. You can see different value attached to it, your error matrix, test accuracy, kappa, recall, everything. So if you go and look at the random forest function inside your model module, you'll see again the same theme. Your training points are split into 75% used for training and remaining 25% would be used for the testing. It constructs one single random forest and then perform your accuracy assessment, and that result is shown over here as a test accuracy, test kappa, recall, precision, etc. So we have generated the rice map based on the data points that we have. Next we'll look at the independent validation based on some of the extra points that were collected in the project. Before we do the independent validation, we have some post-processing that goes. And for the post-processing in this example, we've taken the RLCMS, the Regional Land Cover Monitoring System, developed by the surveyor HKH, in order to remove unwanted pixel. So we're loading the RLCMS for 2020 here, and the visualization is provided here. You can go ahead and run that. Basically, these are the classes in the RLCMS layer. And we're looking at Paro. And now we're looking at the forest class. So we selected the forest class from the RLCMS layer, and we are removing any pixels that are listed as forest in our rice map. So that is one post-processing step that is done, which is visualized here. So removing the forest pixel that are classified as the crop pixel from the rice map. The other way it's done is we're also looking at the crop layer itself. So the crop layer is number 7. This not only include rice but also several other kind of crops. So we also taking the crop layer and keeping our results inside that crop layer. Depending on the accuracy of the RLCMS layer, this may or may not be a good idea to use a crop layer. In this example, we have shown you how you can also use other kind of layers to max out the pixels. If you recall, in the beginning of the video, we saw the connected pixel. So if you want to export that, you can simply uncomment this. This should give you the connected pixel. You can learn more about the connected pixel count in the documentation. So the connected pixel count will give you an image where each of the pixel will tell you the number of the connected pixel in a neighborhood of 4 or 8. So we're using connected pixel here, we're exporting the result, and that is the result that we imported previously. So I'm just gonna comment that back again, and here we are just calculating the pixel area for the image, and next we are basically calculating the area of each of the connected pixel that's obtained from the connector rice map. And now here we are removing any of the connected pixel which has area of less than 3 connected pixel area. So we see 3 times 30 times 30 would give you an area of 3 connected pixel, and any object that's less than 3 connected pixel, getting rid of that. So that would get rid of some of the predictions that's very scattered on a specific location. And this is the third post-processing step that we applied. The first one was removing the forest pixels from the predicted map. The second is keeping the prediction only in the crop layer. The third is using the connected pixel area to get rid of any of the pixels less than 3. And finally, we are now for our independent data points, which are the level 0 and level 1, we'll go ahead and do sampling as we did for our LT2 sampling points. We're doing the same step here for our label points, which is now level 0 dot merge level 1. We're merging both our labels here together, assigning a geometry to it, and then doing the sampling. And the output, then the classified map is used to see the accuracy of this independent validation sample. So that is the result that you're seeing here, independent validation points, the confusion matrix. So this is the accuracy, recall precision on our independently collected validation point. And finally, we are exporting our rice map, which you can do by going to the tags and running the tags. This should export the rice map to your Earth Engine asset, but looks like you need to fix the path, which I called we didn't do that. So let's go ahead and fix our path. The path, we need to make changes in our export path variable in line 37. Before we do that, let's go ahead and make an image collection that will store the rice map export, and I'm gonna put this in a project level, which is inside EE assets button and rice map. And this is the same path that I will provide to my export path variable, which is assets button, and we have a rice map. So the export path is where this should be exported with the rice_2020 as the name of the file. So let's go ahead and run this, and when you run this, your path should be fixed, and you should be seeing your tags tab highlighted. Here you go. And if you run this, now you're inside rice map and rice 2020, and you can go ahead and run the rice map for 2020. Okay, so this concludes our rice mapping tutorial, and we have just concluded part 5. So to recap, we used generate and validate script that uses the best parameters from our previous exercise. We also saw that how this script can be used to perform any post-processing for your rice map, and also do independent validation if you have data available. And then finally, you also saw how you could use the script to export the rice map for the given year, and for this we looked at the year of 2020. In my YouTube channel, you also can find several other videos, so go and check it out. And if you have any questions, any concerns on the code or anything, my email and contact are shown here. Please write to me. Thank you and have a great day. Bye bye.